Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 10, Section 3, Part 4. And we're going to talk about some applications to chemical reactions. So, water hardness. Well, what is that? So if you talk about your water being soft or hard, a lot of times that has to deal with like maybe how your hair feels after you've had a shower, or how well the shampoo soaks up, or how well the laundry detergent cleans your clothes in the washing machine. So areas with a lot of mineral content in their water are said to have hard water, and that means you have high amounts of magnesium and calcium in the water. And some people, so that isn't always desirable because shampoos don't work as well, the soaps don't work as well with hard water, so people will have water softeners to deal with that. So like I said, hard water doesn't let soap and detergents lather, clean, and rinse off as well. So water treatment plants add hydroxide or carbonate compounds to the water to make it less hard. So why do you think a water treatment plant would add carbonate to hard water? So take a minute and think about that. So we will discuss your answers in class. Let's talk about another type of reaction, polymerization reactions. So these are reactions that create polymers. So that is the repeated addition reactions that add a monomer to a growing polymer. So it's a reaction and you add one monomer, and another reaction you add two monomers, another reaction it adds three monomers, and so on and so forth. So one type of polymerization reaction is a dehydration synthesis. So we're synthesizing, we're taking like a monomer and a short polymer, and we're making a longer polymer. Dehydration means you are removing two hydrogens and one oxygen, so H2O. That is removing water, so that's why it's a dehydration. So dehydration synthesis reactions are a polymerization reaction that remove two hydrogens and one oxygen to add a monomer to the growing polymer. So for example, making starch from glucose molecules is where you have a glucose and another glucose, and then you have a growing polymer, and then you add another glucose and you have a longer polymer, and you keep going, probably hundreds of glucose molecules to make starch. And there's a nice picture of that in your book. Alright, so like I said, there's a nice picture of it in your book, and also here's a picture I found online where you have, this is a glucose molecule, and then we add it to another glucose molecule, and we get rid of HOH, or water, and then they join up, and we have two that are joined by that oxygen right there, and then that water leaves, and that keeps going like 100 times to make starch. Alright, so plants make glucose through photosynthesis and then convert glucose to starch for long-term energy storage. So we know that this is a chemical reaction, the reactions of photosynthesis that make carbon dioxide and water and make glucose, and then they do a dehydration synthesis polymerization reaction to make starch, and that's how they store energy and make the plant itself grow. So that is the end of 10.3, and in 10.4 we're going to talk more about chemical reactions and the energy that is either lost or gained or transferred during those chemical reactions. I will see you then.